Today we're going to be working on trig equations. All right? There's nothing else to do other than to just jump right in. So for this problem, I'm asking you to determine all the solutions for x is equal to negative root 2 over 2. And in this case, I'm going to ask you to use radians. I don't really care for angles. You've already done that in grade 11. Regular angles, you've already done that in grade 11. So for this problem, you have to understand that cosine of x is negative. The ratio is negative. And when we use the cast rule, we know that our angle is either in this quadrant here or this quadrant here. Okay? So imagine that the first angle is here. Okay? So there's my initial arm, there's my first angle. Okay? So now we have to use the concept of the root of 2. The negative root of 2 over 2. Now, you know that cosine is in the form of adjacent over hypotenuse, right? So basically, for this triangle that we have here, the hypotenuse is 2, and the distance along the x-axis is negative root 2. So what we are looking for is all solutions for this to happen, okay? Now, when you take a look at this, you're going to find the following. This is actually, if I take the root of 2 over 2 and I simplify it, it's going to end up being 1 over root 2, which tells me that I have my root 2 triangle, 1 and 1, and that means that this angle here is pi over 4, i.e. 45 degrees. So that means this angle here is pi over 4, so that means the angle between here and here is 3 pi over 4 radians. So now, the first solution, let's call it x1, is equal to 3 over 4 pi plus n times 2 pi, i.e. it goes on forever if you think of it that way. So it makes a complete revolution around. So that's my first solution. So for the second solution, I'm going to use black. So we start with black here, and then we end up in this quadrant here. It is still 3 over 4 pi here. Sorry, it is still pi over 4 in this quadrant, right? And when we decide to draw the rest of our triangle here, the root, the hypotenuse is still 2. So now let's go and do our calculations, right? So for the second angle, when we zip around here all the way to the end, this is actually, well, this is 4 pi over 4 radians, otherwise known as pi radians, but then we add a fourth. So the overall is going to be 5 pi over 4 radians. So our solution is x is equal to, let's call it x2, is equal to 5 pi over 4 radians, okay? And once we have our 5 pi over 4 radians, we have to add n times 2 pi, which is a complete revolution of our circle. So we have a coterminal angle, and we're done. So for this next problem, you're given the square root of 3 sec of x is equal to 2, and x can belong to any number. What I need you to do is I need you to find all the solutions. And in order to do that, we start by doing this. We don't really know what sec x is, but we do know what cosine is. So the first thing that we're going to do is we're going to change sec x to equal 2 over root 3. Then we're going to flip it to get cosine of x is equal to root 3 over 2. Now, as an aside, remember the right triangle that works with that is a triangle that has an angle of pi over 3 in the corner, pi over 6, root 3, 1, and 2, i.e. 60 degrees in the bottom right corner, 30 degrees in the top right corner, and root 3 and 1 for its legs. So now the solutions are basically given by this. So if I actually looked at a chart, we would see the following. You'd have, because this is positive, let's assign that, because this is a positive ratio, our values are in this quadrant based on the cast rule, CAST. Now, because of that, we're going to be able to create two different triangles, right? One above the x-axis and one below the x-axis. Now, because this is cosine, you know that cosine is described as the adjacent over the hypotenuse, otherwise known as, in our radian measure, the x value over the r. So the r in this case is 2 and 2 on both of these triangles. And the x values along here is root 3. Now, based on that, we can calculate our triangle. So our triangle is basically this angle here, because the adjacent is 3 and the adjacent is 3 and the hypotenuse is 2. So we know that this angle here is pi over 6. And then to go from here all the way around is going to be 11 pi over 6 to get to that spot. Now, so therefore there are two solutions. So here's my first solution. I'll call it x1. x1 is my pi by 6 solution. So I got pi over 6 plus 2 times, ready? No, not 2 times, plus n times 2 pi. And here is x2. x2 is going to be, well, remember, it's 11 pi over 6 to get to that spot. So we're going to have 11 pi over 6 and then plus n times 2 pi. And we're done. And all we have to say for each of them is n belongs to not real numbers, but integers. Please try to remember the n belongs to integers. If you miss it a couple of times, if you miss that a couple of times in on your test, I'm not going to penalize you. Just try to do it more often than not to tell me that these solutions have integer values for all of the n values. So for this next problem, we're going to be solving our equation for tangent. Okay, so we need to solve the tangent of these problems. All right. So if you look at all of these equations, right, you could literally notice that we have tan squared x plus the root of 3 minus 1 plus times tan of x minus the root of 3. Well, this thing actually factors to literally this. Tan of x minus 1 times tan of x plus root 3 is equal to 0. So now there are two solutions to this. So if you can factor a quadratic, you can do these problems. So in this case, the first bracket is tan of x minus 1 is equal to 0, and the second is tan of x plus 3 is equal to 0. So you solve for both of these and you get tan of x is equal to 1 and tan of x is equal to negative root 3. So for my first solution, The only time tan is positive is in this quadrant and this quadrant based on the cast rule. Okay, so that means we have two possible triangles that are created in each quadrant. Okay, now this side is 1 and this side is 1. That means this side is -1 here and this is -1 because it's below the x-axis. All right, now what that tells me right away is my problem when I have a triangle that has 1 and 1 as its solution. It's a triangle that looks like this, 1, 1, and √2. And we know that this angle here in here is 45 degrees, otherwise known as pi/4. So that means our first solution is, if I start from here and sweep around for this, we have x1 is equal to pi/4 plus n times 2 pi. We can also make another solution for it, and you can say x2 is equal to not pi/4 but 5 pi/4. That was 5 pi/4, and the x2, which is the line that goes from here up to here to get to that, okay, is going to be, well, it's going to be pi/4 plus n times 2 pi. So that is your first solution for the left side of our bracket. The right side of our bracket has two solutions again, but this time, because they're both negative, those two solutions are in this quadrant here and this quadrant. Oops. Because tan is negative in those two quadrants. So our triangles are going to look like this. One looks like this and one looks like that underneath the x-axis. And then all we have to do is use the concept of, oh, wait a second, we have a tangent having a √3 in it. If we have a √3 in it, we have a triangle that looks like this. √3, 1, and 2, where this is pi/6, no, pi/3, and then the top corner is pi/6. So now all we have to do is solve to get from here to here. Inside this little triangle here is going to be pi/3. So the distance from here to here is really 2 pi/3. Now, let me just show you why that is on the triangle. So basically, you know that tangent is opposite over adjacent. So this part here, so this part along the x-axis is -1, and then its height is √3, which means that this angle here inside here is pi/3 based on our original triangle. But to get from here to here is actually basically 3 pi/3, which is 180 minus 60 to get that answer. So you get 2 pi/3 plus n times 2 pi. Now let's do x4. x4 I'm going to do in black. So x4 starts here and zooms all the way around to here. Now to get to the very end, we would normally have 6 pi/3, but because it's 6 pi/3 and the angle inside here is pi/3, here's what we have to do. We take 6 pi/3 minus pi/3 gives us 5 pi/3. plus n times 2 pi. And there we go. And for all of these, you must say that n belongs to integers for every single one of them. Okay? And that's how you get your solutions. So for homework, you're going to do page 241, number 1, 5, 7, 11, 13, 17, and 19. Okay, now 13 through 19 will be a little difficult, but you can do it. Good luck. On second thought, change 13 to question 15. So you're going to do question number 15, 17, 19, and 20.